Okay, let's give you guys some practice. So here, given this function here, f of x equals root x minus 5. Well, given this function here, state the domain of this function, state the range, and what do you get when you put 9 into the x here? Okay, but in order to understand what's going on, try to understand this graph here. Once you've got a picture of this graph, then you can easily work out the domain, the range. Well, this here you don't actually need to understand the graph. You can just put 9 into here. But given a function here, try to understand the graph. From the graph, work out the domain and the range. Okay, but just for now, let me just explain what this graph will look like. Okay, so rather than looking at this, let's try and simplify things. What happens when you have f of x equals root of x? So it's like you drawing a graph of y equals root of x. Okay. Now look what happens. Hang on. When you plot a graph of y equals root of x, it looks like this. So something like this. Okay. So when you plot a graph of let's say f of x now equals root of x, you would create a table like this. When this is x, this is f of x. Now when x is 0, you would square root 0, so giving you 0. When x is 1, you would square root the 1, which would give you 1. When x is 2, then you would jump to your calculator, square root of 2, whatever this number is. Okay, I'm just going to leave it as root 2. And when x is 3 and so on, you would root 3. When x is 4, it's actually 2 because the square root of 4 is 2. Yeah. So now you see this graph here. So this function here will create this graph here, because from here you would create a table like this, just so that you get a picture of what's going on. And when you plot it, it will look like this. Now look what happens when you try and plot this one here. So you can imagine this as being like there being a bubble here. Now when x when you put when you create your table like this, x here, f of x here. Now when x is 0, well, when x is 0, if you put 0 into here, you're going to get negative 5. Now two things you need to remember. You cannot square root a negative number, and the other thing that you need to remember is you cannot divide by a 0. So whenever you have something like this here, the function breaks down. Well, when you have 1 divided by 0 or whatever divided by 0, the function will break down. Here you've got your function here. This is your function here. It will break down when this bubble here when this bubble here is less than 1. When it enters a negative realm, when this bubble here enters a negative realm, the whole function breaks down. So hang on, look at this here. When you create your table for this one here, when this is x, hang on, when this is x, when x equals 0 here, if you put 0 into here, then you in effect will be trying to square root negative 5. Now negative 5, it breaks down. So here it breaks down. When it's 1, when you put 1 into here, you are in effect trying to square root to negative 4. It breaks down. When you try and put 2 into here, you're in effect trying to square root 3. Again, it breaks down, and so on. It starts to work when you get to 5. You see, when you put 5 into here, this is like you trying to square root of 0, which is like this. So this here will be 0. You see, it starts working again when you get to 5 or above. So now 6. When you put 6 into this thing here, 6 take away 5. That's like you square rooting 1. You see, it repeats itself, and it turns out to be like this. Hang on. It turns out that, well, a graph of f. You see, at the moment this is f of x equals root of x. This is what you've got so far. But when you Well, when you want to investigate what happens when you have f of x uh, equals root x minus 5, this is what this will it will look like this. It moves across like this. You see, it moves across like this. So it starts working again when x gets to 5. Now you put 5 into here, it will be in effect root 0, which is like what you had earlier up here. Now if you put 6 into here, this is like you doing root 1, which was what was here earlier. Basically it gets shifted across. Well, anyway, this is this function here is given by this. Now now that you've got a graph here to represent this function here, you should be able to work out the domain, the range, and well, this here you don't actually need the graph. You just put it into here. Well, anyway, press pause and have a go. What is the domain here, and what is the range, and so on. Okay, so press pause and have a go. Okay, so here the range is what the range is basically the x values where you can put it into this thing and it still makes sense. So, well, if you try and put, let's say, 2 into this thing here, it won't make sense because you in effect be trying to square root -3. You see, the domain here, while looking at this graph here, the domain the domain is basically everything everything equal to or greater than 5. So the domain here, you would do it like this. Hang on, squared bracket, because you can't include the 5 itself. So 5 here, comma, well, everything up here towards infinity. Okay, so your domain would be this. So square bracket 5 comma infinity, and then this here, and then the range. Well, the range here is everything up here. Everything. Well, the range will be this here, comma, and then infinity, because yeah, the range is everything above here. And what happens when you put 9 into this thing here? It will, well, it's like you putting a 9 in here. So it will be root 9 take away 5 is 4. So this here is 2. Okay, so this here f bracket 9 close bracket, it will be positive 2. Okay, so if you were to do this here, 7, 8, 9, and then go up here, this here would be 2 here. Okay.